Hi everybody, it's time to practice some C again, and today we're going to have a look at how to perform DNS requests in C the good way, how it's supposed to be done. Now, I haven't done this before, so we're going to learn together about the exact steps that need to be followed, and I would say let's just jump right in and create a directory called DNS, and let's cd into that and create a new file, vim.dns. And after this video, at the end of this video, I want to be able to have a small C program where I can specify that I want to send, where I can specify a website such as google.com, and then C will tell me then the program will tell me the IP of Google. Yeah, so we can basically specify any host name and get back the IP of that. So how is that done in C? That's something that we will find out in this episode. And before we do anything, let's include what we are going to need. First of all, let's create a main method. Today we're also going to include a return value, which I usually omit because this is technically it's not a necessary line. And let's print f performing DNS lookup. And then what we have to do is we will code some DNS lookup logic here. And then we can save that, and in this right-hand pane below my webcam, we will compile that stuff. So let's cd into that directory as well. Let's gcc that file, let's compile that file. I will call the output DNS, and I will specify as input dns.c. I will also specify that I want to enable all warnings, and I want to have debug flags enabled just in case we're going to have to debug something. And there's no warning. Let's execute the application, and there's the printout performing DNS lookup. I forgot the new line at the end of this, and now we're good to go. So this is our starting frame of a program, and the function that we're going to use for performing DNS lookups is called, wait, let me just create this setup here. Okay, it's called getaddressinfo. Okay, so this is the manual for the man page for this function that we're going to use, and it's a very simple function actually. We just have to deal with the details which make it a bit harder to deal with. So the function is called getaddressinfo. We specify a constant character pointer, so a string node, which is the host that we're requesting the lookup for. Then the service, which can be, I think this can be, well, whatever name of the service that we want to query for, HTTP, things like that. Then a struct address info with hints, the kind of address that we're looking at. So we can give that lookup hints, such as the protocol we're using, I think. Wait, let me just search for hints. Okay, the hints argument points to an address info structure that specifies criteria for selecting the socket address. Structures returned in the list pointed to by result. Yeah, and the result is this thing, this last argument, which is a pointer to a pointer of a result, and this is going to be filled by the getaddressinfo method. Orange tea, by the way. All right. So I would say the first thing that we can reasonably do is we can just copy all of that, and maybe also the free one, because at the end we have to free the memory allocated by address info, otherwise we get a memory leak. And then let's paste that here. I can just move up the include statements here and then indent them properly. And then getaddressinfo returns an integer, which is an error code. We don't need that one for now, I think. Maybe we need it later. And then we free the address info. Then we get as a response the struct address info, which we have to free at the end. And this needs to be allocated on our side, I think. I think we need to create the address info here. Address info results. Let's call it result and write out the full name. I really dislike that all the variable names and all the type definitions and all that stuff is always abbreviated in C, which makes everything very hard to read. I'm coming from a different programming language, so maybe I'm a bit inclined toward writing out stuff, but yeah. I mean, on one side, it's cool to just hacker-like abbreviate everything and still understand it. But for someone looking at code for the first time, it's horrible. Then, so this is the result. Struct address info, and we need to pass a pointer probably. And then we can pass that here, p results, and I'm using the p, which is the Hungarian notation, to prefix the result, because it's a pointer, so just to be sure. Then the node will be a character pointer, which is basically a string, const character pointer. Node, and the node is, let's just hard code it for the first time, www.google.com. And then the service will be constant character pointer service HTTP. Let me just have a look at the man page again, just to be sure that I'm not misunderstanding something. So service is service sets the port in each returned address structure. If this argument is a service name, it is translated to the corresponding port number. Okay, so if we specify a specific service, such as HTTP, then it will probably default to the port 80. So actually service is the port number. It's just a generic, name, or it's a generic wrapper around the concept of a port. All right, there's even a code example here. That's nice. So let's see if we can make use of it. First of all, I'm going to pass the node here and then the service here. So for HTTPS, the port would be 443. For HTTP, it would be 80. For, I don't know, FTP, it would be, what's the port for FTP? I forgot. 8181? No, that's not, no. Yeah, you probably know what I'm aiming at. Service, and then we have to construct the hints. So the hints are constant struct address info hints. And let's have a look at how the hints are created here. So the hints are, as you can see up here, allocated, they are declared here. And then down here, the hints structure is zeroed out, just so to ensure that there are no wrong entries, because the memory is just declared but not written over. And then we can specify things such as the family, which is the IPv4 or IPv6 family. We don't specify that. Then we can say that we want to have a specific socket type. We want to say that we can specify that we want to have a specific, I don't know what that is, wildcard IP address. No idea. We accept any protocol. So let's just copy that block and go here and paste this. I mean, this is coming from the official documentation, so why not use it right away? Let me just highlight all of that and then, highlight and indent, then press the dot key to indent it again, and then the dot key to indent again. Something is wrong with the indentation here. Wait, now I have to probably fix it myself. Okay, now it's good. So we need to first set all the bytes to 0, to zero out the address info structs, to zero out the hints struct. And for that, we have to include the memset function, which is, as far as I know, part of standard lib.h, I would guess. No, well, it's still complaining about an implicit declaration in line 17, which means that memset is not included. Maybe it's part of string.h. No, strings.h maybe. Yeah, it might be strings.h. No, it's just throwing another error because I introduced a typo here. Okay, let's find out where this is defined. memset. So here we are filling memory with a constant byte, and it's part of string.h. Okay. That means let's include string.h, and then this error should actually go away. And now here there's an error in the size of call, invalid application of blah 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 something. Let me just compile this with the compile flags, with the warnings enabled, and let's see what the warnings are. And here we have an error, assignment of member in read-only object. So we have why is the object read-only? I would say because it's a constant struct. But I was wondering, because I just copied this from the official documentation here. So wait. So here the hints are required to be constant, but of course before they are assumed constant, they must be set somehow. So probably in the code example down below, they are not constant, at least not during the declaration. And let's have a look. Yeah, the hints are declared without the const keyword. Okay, then let's just remove that and hope that it works now. And let's see if we compile this again. Now we get a lot less warnings, a lot fewer warnings, but we still get some. There's an expected expression before const struct address info hints. Of course, here I have to remove this construct and just input the hints. And then let's fix up this layout here. Now, what is wrong? Variable has incomplete type struct address info. Maybe I need to include something, because if I look up man address info, oh, it doesn't exist. Wait. Wait, what is the error here? Let's try to compile again and see the warnings. Incompatible type for argument 3 of getaddressinfo hints. I think I know the issue is that we are declaring a structure here, but we are passing as input the structure itself as a value, but not as a reference. We have to pass a pointer here. Let's see if that fixes the error. Yeah, so one warning is gone. Then there's another warning, passing argument 4 of getaddressinfo from incompatible pointer type. P results. Yeah, of course, same thing here. We have to prefix this with the ampersand to pass the address of that and not the structure itself. And then, I mean, not the pointer in this case, but this is expected to be a double pointer, a pointer to a pointer. So we have to prefix with ampersand the pointer. All right. Then in line 28, expected expression before struct, free address info. And of course, yeah, that's because I haven't fixed up this here, this down here, the free address info call. Here we have to free up the P result. And I don't know if this needs to be a pointer as well. Wait, let me just undo the change and check. This is just a single pointer to an address info, so I think P result might be good enough. And if that works, then we are good to go. We have no warnings here. There are some warnings in my linter in Vim. I don't know why. Variable has incomplete type struct address info. Why is this an incomplete type? It's probably not imported somewhere. It's probably not included, I mean. So let's see here on here which include statements we could be missing. I will just copy all of them because we probably need all of them. And let's go up here and just paste them. Fix up the indentation. I'm always doing it in the wrong direction at first. So we can delete this, string.h. Yeah, okay. I don't like that there's an error here, but the compilation is completely fine. What if I pass W extra? It doesn't do anything. Okay, so we are getting address info. And I would say the next thing before we continue is we should check in the debugger if the address info result is actually being filled. And to do that, we use GDB, and we do that in a new pane. What do they call the project again? What are we even doing? DNS lookups. Yeah. Then GDB, and let's call the DNS thing, and then layout next, and go to the source view. Let's start the debugger, printf, refresh to fix up the screen because we've printed something to the console. And now we're good to go. So for now, the address info that we're passing, the p results, is empty. Well, okay, yeah. It's just a pointer to the address 0. It's not even allocated. Then we create the node name, google.com, service name, and then we memset this address info structure. So let's print the hints, print the hints. And here we can see that all the values are now 0. So here we have the flags, they are 0, the family is 0, socket type is 0, and protocol is 0. All that stuff is 0. Then we set those fields one after the other. And if we print out the hints again, and we can see that the values are now set. They are set to 1, 0, 2, 0, 0, 0, 0, 0, which are the null values which we passed here. And then if we do get address info, then I would expect that this p result array, the p result pointer actually gets some reasonable value. So wait, let's check out the value of p result. It's 0, which is the address it's pointing to. If I dereference it and do p result like this, this looks quite empty. I don't know if I'm debugging this correctly, but let's do n and then let's print p result again. Oh, I printed result and not p result. That was an issue. So here, this definitely went wrong. So if I dereference p results, yeah, of course, we cannot access memory at that address. I think we have to allocate the memory, and let's see if that is even done here. So here the result is passed, but where is it declared? It's up here. Yeah, and then we don't have to allocate the memory. The function will allocate the memory itself for us. And then the value of that pointer, the address it is pointing to, is updated, I think. But I suspect that get address info for some reason fails. So let's check the result of get address info and compile this again. And it's now an unused variable. That's fine. We just want to check the result in the debugger. So let's go into the debugger again. Let's set up everything again. Layout next. And let's set a breakpoint at after we're getting the result. So in line 31. And then let's run the application. And here we are. And let's print the results. And it's -8, which doesn't sound too healthy. So let's look up the return values of that function. Return value. Get address info returns 0 if it succeeds, or one of the following non-zero error codes. So it's one of those. Something is wrong. I would say maybe it is the out of memory thing. That would just be my best guess. Can I print those out to the console in the debugger and check which one it is? What if I just say EAI fail, print EAI fail? No, that doesn't work. Then maybe we can do it in a different way and just look up those in the user library no, in the user include, where all the header files are defined, and there should be EAI fail somewhere in here. And there it is, and it's probably the net database thing. EAI fail, and let's see. And there are the error values here. Now this one is -4, and we got the -8, which is EAI service, which means service not supported for AI socket type. Okay, what service do we pass here? Ah, okay, and that makes sense. That's why I love debugging. Without debugging, you can't find that out without putting in hundreds of print statements. So the issue that we're seeing is that we specify we want to check the HTTP service, but here the socket type, here we specify that we want a dgram socket, which is a datagram socket, which is the UDP protocol. And as you know, HTTP works over TCP/IP and not over UDP, so the socket won't work. It needs to be a different socket. Actually, I don't care about the socket type. I want to just return any. So can I just put null? I mean, the hints is just a filter for the result. So we should just be able to put null. Actually, if we want to restrict it to TCP services, then it should be the socket, I think socket stream or something like this. Yeah, but let's try to put null. Null. I think it should work. And let's try to compile this again. I still get warnings because I have. Oh no, I get a warning because of this null assignment here. Maybe there's a socket type any. Can I look that up here? Socket type is not supported. Okay, we know that now. Now, the AI socket type. Where's the manual? Ah, we looked it up here. Getaddressinfo. If I look for any, then there's address any. Okay, that's not what we want. That's a wildcard address, but I want to have a wildcard socket type if that's possible. Yeah, the socket type specifies the preferred socket type, for example, socket stream or socket dgram. Specifying 0 in this field indicates that socket addresses of any type can be returned by getaddressinfo. So we need to put a 0 here. Perfect. And now we can compile and just get this warning about the unused variable. By the way, I just learned about a hack to get this warning suppressed, although it's not very useful, but you should handle unused variables properly, but we can just cast it to void int, just like this, and then no. What am I even doing? Results. And then that variable is used. Yeah, and now we get no warning. And let's just put a documentation here so that nobody is confused here. Sneaky way to suppress unused variable. I just need result for debugging. Yeah, so we could do that, or we could actually print out the result if it's not 0. But let's keep it that way. We are hackers. This channel is for hackers only. Let's compile and it works. And then let's go to the debugger. Let's quit and run that again. Layout next. And then let's create a breakpoint at line 33, break 33, and run. And here we are. Let's print the results. It's now 0, which means that the request was successful, which is awesome. And that means I can now print the p result, which should contain the result of the DNS request to google.com. Print p result. Now it contains a value which is, yeah, okay. It contains an address which it's pointing to. And if I dereference that, what happens is I get there's a structure and it's containing values. So we get a result here, and this is the first result. And as you can see, there's even a next result here. Address internet next maybe, or I don't know what the AI here stands for. And this points to the next result. So now the question is just how can we properly print out those structures? And this is what is it? What kind of data type is it? Wait. The p result is a data type address info here. Address info. And as you can see, the address info structure used by getaddressinfo contains the following fields, and there's AI flags, family, socket type, protocol, address length, address, canon name, AI next. What is the canon name? Canon name. The AI canon name field of the first of the address info structures in the returned list is set to point to the official name of the host. Okay, so maybe that's something that we can also print. I don't know. Yeah, it's just a character pointer. So now we have to loop over the results and print them out. Print results of DNS lookup. So while, and we want to do a while because we have to iterate over the results, because there are multiple results in this object that we fill. Now this is getting complex. Now the C part, the C syntax part starts. So we have a pointer to a pointer. Wait. Oh no, let's be clever. We just look up the documentation which already contains something, maybe? Yes, there's a loop. There's a loop that we need. So here we are looping over the results and we're accessing the next DNS result for every iteration. So how is this done here? Get address info. Where's the get address info call? There it is. We are filling values in the results here. The first value we're iterating over is this. While it's not null, get the next result. I will do this a bit differently, I think. Oh no, let's stick to the documentation just so we don't unnecessarily complicate our lives. So for RP equals P results, so RP is also a pointer. I think the RP probably stands for result pointer in this case. Yeah, so our syntax or our naming convention is not really met here consistently. Then, so that's the initial value. Then while RP is not null, give us the next results. RP is equal to RP, and then we access this thing here, AI next. Although not strictly this field, because this is from the hints object, but it's the same data type, I think. And here we're looping over the results, and then we can print out printf DNS lookup. We can print out once the DNS lookup for, and then we say for a string, and we are looking up for a given node that we passed initially. And the node is, in our case, hard-coded here, google.com, right here. And then the next thing to do is we print f, of course. So DNS lookup for google.com is what it will print out, and then we print as a next result, as a next line, we print, my brain is not working, wait, give me a second. Address info. Here, okay, we are printing out the AI family. The family is, I think, IPv4 or IPv6. Yes, there are two types of families, INET and INET6. So let's print that out. Let's say printf. Oh no, let's check if RP and then AI family is equal to AI INET. Then printf IPv4 IPv4. Maybe like that. No, let's do it all in the print statement. I didn't like that this is so unconcise. This is so verbose. Family is, and then we pass a string here and a new line. And then we check if the RP AI family is equal to AI INET question mark. So this is the ternary operator as far as I know. And then we return IPv4. Else we return IPv6. Okay. So this is a bit more concise. Then we of course want to printf the address, IP address, and this is of course also a string. And now the big question is, how do we get that string? Because this structure here contains an AI address, but it's a structure socket address, and the socket address is not, it's not a simple string. Wait. Sock address. Or let's search for AI address. I think I will look up that structure socket address here. Or is the canon name maybe already the IP? Wait, let's not complicate our lives and let's print the canon name. And then like that. And then we pass RP AI canon name. And this should work. Of course, we don't printf, but printf. This was a typo. And I don't get... there's also an issue. I didn't get why all these R's in the RP are highlighted, and that is because we have not declared the identifier RP. That means we have to say that this is a... We have to specify the data type for that, of course. And the data type is address info. No, it's not. What is the data type? I think it's just address info. But let's look up here. Yeah, it's address info. It's a pointer to an address info. Struct address info pointer RP. And maybe we have to dereference the P result here. No, wait. Let's just take some time to understand this. Wait, let me just extract that variable here. Address info RP, and then let's do this. So RP is P result. Okay, I will compile this just to get all the warning messages, because this is more helpful. Oh, there's an error AI inet undeclared. It's AF inet. Of course. AF inet. And now what do all those warnings here mean? I don't get an issue with the compiler. And it's coming from this warning flag here. Let me just compile with that locally. No. So let me go down to this, highlight it, and then go over here and let's clear the screen. And then here, let's paste it. Oops, what did I do? Oh God. Right. Let's clear the screen, do this, and then let's add this flag like this. Okay. Unrecognized command line option, W for loop analysis. Okay, it seems that my linter program uses some magic warning option that we don't have access to. At least not in GCC. What if I do CC? No. Usually I am inclined to fix warnings, but I have enabled all warnings here, so the code should be fine. What if I just execute it? Okay, we get two results. One is IPv6 and one is IPv4, and both have, and neither has a canon name, whatever a canon name actually is. Let's try to print the socket address. Yeah, let's try to print the socket address. And let's delete the canon name because it's not very interesting to us now. The address is something, some string, new line. And what is the content of the address? I know there's a helper function for that, and it's called network to presentation. Network to presentation. Maybe it's used here. No. Let me just grab through the libraries. Network to presentation and top. There's a lot of stuff, not a lot of inets, a lot of results here. I think it's coming from the inet header file. And top. Yeah, so here we get exactly. Wait, some of those methods are probably useful to us. Inet and top. We pass the address family. Then something, I don't know what that is. That's just an inet and top. No, I'm not sure about those. Let's try to get it from the documentation somehow. The address info structure is used by getaddressinfo contains the following fields. Structure socket address. Let's look that up. Man sock address. Why is there no entry for that? Socket address. I thought that this is a more important data type in C, so I can expect it to be defined somewhere. Man, maybe in socket. And here maybe someone uses socket address. No. Address. So the problem right now is that we have the address and it's in memory and we can work with it technically in C. The problem is just that we want to represent it in a human readable format, not just as bytes in the memory. Because we can go to the compiler and let me just show you. Quit, Q, yes. Layout next, and then let's start the application. Let's set a breakpoint in line 33 as before and then run again. Oh no, I have messed up something. There's no code in line 33 now. Okay, and basically at this point right here, the address info is filled. So if we do print rp, no, that's not the address info. The print p result is the info, print p results. Then print that, but dereferenced p results. So that contains all the info, as you can see here. We can probably also print p results AI address. And this looks like some data. So as you can see, there's some binary data which encodes the IP address. And if I do the same debug statement, but with an arrow operator, maybe the result is human readable. No, this is not human readable then. But let's still try it and see. Yeah, it's the same thing. Yeah, so this IP address is just data. So let's look up online as a data to readable socket C. Yeah, so we get a resolved IP address, but the SA data is just this. How can I print it? Maybe sock address. Oops. Let's look at this BJ's Guide to Network Programming. This is quite recommended. I currently read it. Get address info, and then in here we want to print here, convert the IP to a string and print it inet ntop, so network to presentation. The network representation format of the IP address is just the bytes in memory. And we want to represent it somehow. So I think we can just use this inet ntop. Is there a manual for that? Inet ntop. Yes, there is. Awesome. I could have looked that up instantly, actually. Okay, so this converts IPv4 and IPv6 addresses from binary to text form. Yeah, that is the thing that we're trying to solve now. And we can just copy that. And go to our code, and then here, let's create a new line of code and convert IP address to human readable text. And then let's paste that code in here. And then what we need to do is store the results in a readable IP address. We can use that in the printout statement here. IP address, like this. And then we have to specify the AF, which is the family. Yeah, the address family, IPv4 or IPv6. And we already know that from the previous results here. We have this variable, which we can use. So let's reuse it here, RPAI family. And then we pass a constant void pointer source. What is that? What's the source? Converts the network address structure source in the AF address family into a character string. What do I pass for the source? It's just whenever you declare something as a void pointer, it's not very helpful. And here this documentation says in case of AF inet, the source points to a struct in address. In case of AF inet 6, so in case of IPv6, the struct points to a structure in address, in 6 address. So there are different address types apparently. So maybe the address that we're looking at is, or the struct that we're looking at is this socket address. Could be. What if I just pass the RP AI address, and then as destination I pass, what do I pass here? Dest. The resulting string is copied to the buffer pointed to by destination. So is the name returned, or is it passed into this pointer, into this buffer, which must be a non-null pointer? Wait, what is it even returning then? On success, inet ntop returns a non-null pointer to dest. Huh? So we have basically two ways of returning the data, either this or this. So this is a non-null pointer that contains our data. Okay, that means we have to allocate a string. And we have to basically guess how long the string is going to be. But okay. But what is the guide online doing here? IP string. And what is IP string? It's allocating a character array that holds at max IPv6's address length. That's good. That makes sense. Then let's try to do that as well. And the IP string is, oh no, let's do it down here where we actually need it. So we have this IP string, and then we paste that into the method here, IP string. And then we need also the length of the IP string, which we can get either by saying inet6 address length, or we can directly say size of this array, size of IP string, which the guide was doing, if I just remember correctly. Yeah, but the guide does it without the parentheses around it. Anyways, I think this should work. Let me try to compile. And right, I need to use the correct compilation statement. Implicit declaration of function inet ntop. So I haven't declared that function. Yeah, okay, I haven't, because it's coming from arpa inet. Therefore, let's include it. Include arpa inet.h. And this should do it. There's still an error, but nothing in the compilation, so I will trust that. And let's try. I think we can try. Maybe before we print out those things, let's print out the address indented, just so it looks better. Okay, and then let's go and try to clear the screen and, oops, compile this. And let's perform a DNS query. Lookup for Google, and as you can see, that's Google's IP address. They have a fancy IP address. That's crazy. 2.0.0.80. Crazy. That's That's a nice IP address. Wait. So, okay. That's the IP address. Can we print anything else? Maybe a port or something? Let's go to getaddressinfo and check here. The socket type, okay, we don't need that. The protocol, we don't need that because we know it's TCP. Address length, address, canon name. I was expecting something like a port, but we are checking. The hints can contain a port, but the result can't. Anyways, okay. I think in that case, I'm happy with the results. The only thing that I want to change now is I want to accept any input via input arguments. So let's accept argc here and int argv, character pointer argv, which is an array to a string, array to strings, array containing strings. And then if the argument count is not 2, then we printf a usage, DNS, and then hostname. Maybe like this, hostname. And then let's printf the requested. No, we print that later. Performing DNS lookup for this, and then we pass in the argv. I think it should be 1. The argument count should be 2. And aside from that, the node will be not a hard-coded google.com, but it will be, what will it be? argv 1. And the service, actually I don't want to have only the printout for this HTTP service. Are there any others? Or do I have to specify a service? I have to, I think. Service sets the port in each returned address structure. If this argument is a service name, it is translated to the corresponding port number. This argument can also be specified as a decimal number, which is simply converted to binary. If service is null, then the port number of the returned socket address will be left uninitialized. Either node or service, but not both, may be null. Okay. By the way, what happens if node is null? Where do we send a request? Quite interesting. But let's try to set service null and see if we get more results. And then let's go over here and compile and execute DNS, and we should get a usage printout. And indeed, we get it. Of course, I forgot to, in case the argument count is invalid, we of course have to return. And then let's return an error code that this has failed. So it's a non-zero error code. I know you shouldn't hard code those. They are system specific and there are macros for that, but for this project, let's forget about it. And then at the end of this print statement, I need the new line. Oh God. And now let's see. Now we get usage DNS hostname. So that's DNS and then google.com. And now we get more results. Probably there are different services available on those IP addresses. So it would be nice to be able to print them as well. How? We just have to check the resulting object here. socket type, maybe. Family or protocol. Well, they must differ in those fields. Family, socket type. So can we do something like socket type and then print that, and we pass here RP, and then what can we pass? A protocol, not the socket type. Yeah, the socket type is just socket stream or socket dgram. I want the protocol, AI protocol. Protocol. And that's a string, and we accept RP AI protocol. And what does protocol even contain? It contains, it specifies the protocol for the return socket address. And I would say this should differ. But which protocols are available? That would be useful for printing it out. Okay, let's just first try to print it and see what happens over here. And we get a warning that this is not properly formatted. It's an integer that is printed out here. Let's try again. And we get different protocols, so those are hard-coded values. And now we just have to find out what those protocols are. I wouldn't know where, so let's look up sockets protocol. No, what do we look up here? Okay, there's, for example, IP proto UDP. So technically we could hack this, the documentation, and say IP proto UDP and search for that string, get a couple of results. I don't know where to look at, but maybe let's check here. IP proto UDP, IP proto, yeah, and those are the protocols. And we could now technically create a switch case for all of those protocols here. But let's just stick to the basics. We had the protocol IP, which is 0. So let's code that. The protocol. Let's do character pointer protocol and then switch over RP AI protocol. Let's just code a couple here. Protocol and then case. In case the value is 0, IP proto IP. In case the value is, oh my god. In case the value is 0, then protocol is equal to IP. In case it's 1, the protocol is, what is it then? No, we're not going to hard code all of them. Let's just continue with this 6. So in case the protocol is 6, then it's TCP. And in case it's, let's also add the UDP one. UDP is 17. And what else is there? What did we get in our printout? We got 0, 6, and 17. Oh, so those are all. And maybe default is protocol. Ah no, let's not use a default. Oh no, let's use a default, and the default is that number to A to I. No, I to A of that number protocol. So we want to have that integer as the number, and the integer as the string. I to A of the RP AI protocol. I hope this works. Protocol. And I to A is not defined here. Why? What do I look up? I want to convert a number to a string. C, convert integer into string. There's sprintf, which was also already recommended to me in the comments. But isn't there a simpler way? Yeah, I to A. But it's more complex than just that. Than just having a single input. Okay, let's try to use sprintf. So let's allocate a string protocol default case. In the default case, we do this. No. String of, let's say we accept up to, I don't know, 100, no, that's way too much. 10 characters. And then the protocol is sprintf of the string or can we write directly into that protocol string? Can we write directly into the protocol string? Maybe I have to allocate something here. Malloc is equal to malloc. Size of character multiplied by, and let's say 10. And then we write directly into the protocol the number AI RP arrow AI underscore protocol. All right, I hope this works. Break. Does this work? Did I mess up the syntax? I have no idea. The protocols are not pretty printed for some reason, because down here I'm still saying that I want to print out the protocol number. Of course, I want to print out the protocol string now. And I think that might be it. Let me have one sip of my tea again. And now it's time to finally, for the last time in this episode, test our own DNS lookup in C that we coded from scratch using just documentation and a couple of lookups here and there. But we coded our own DNS lookup in C, which is awesome. Awesome thing. We learned a lot of stuff. We learned how, well, let me talk after executing this. So here's our execution, querying google.com. And there we go. So google.com exposes this address and makes available the TCP service. It exposes this address and also makes available UDP here. So that's just probably a different port. Then IP, TCP, UDP, IP, of course. And those are the addresses. Google has an awesome IP address. 2000. What if we query youtube.com? They also have 2000. And what if we query facebook.com? They also have 2000. What? Maybe something entirely different. Reddit.com. Did I mess up? Wait, I am passing as input the host name. Here the node is argv1. Get address info for the node. Let's check in the debugger, because this cannot be. I can't have messed this up now. Layout, next. And let's jump right into the call right before performing the lookup, and it's the get address info call in line 35 now. So let's break 35. Let's run. Process exited. I need to provide arguments. Arg google.com. Wait. I have noted a couple of days ago in a small little booklet, commands for GDB. Wait, there's a command to provide arguments. Set args. Okay. So we can do the following: layout next, then jump to the source code, set args, and then google.com. And now we should be able to run the application with that argument. And then we go right to the lookup. Where is it? Yeah, line 35, break 35, and let's run. And here we are. Let's refresh the screen. And then let's print node. Node is google.com. Let's hit N. Let's print the results. That is fine. And let's print P results. And that also looks fine. Maybe something is wrong with the arguments that I'm passing. Maybe I shouldn't just pass. Maybe if I pass google.com, it returns, or just an address.com, maybe that returns something differently than if I, maybe that returns the address of where google.com itself would be looked up and then resolved to www.google.com and stuff like that. I don't know. Let's try with www.google.com performing DNS lookup. Yeah, probably it's blocked by this. Let me close that. Is it stuck? What? Why is it stuck now? Wait, let me just kill the process in case it still runs in the background. If something is stuck, then usually that means there's still a process running somewhere. But there is none. It's just tmux bash vim. I think I know what's going on. My internet connection is probably down. Wait. Wait, if I... Yeah, as you can see, my internet connection is down. Okay, I am now back. I've had to restart my computer because the internet connection was gone. And then I noted that I don't have that much time anymore, so I had to leave and work out a bit and go for a run. And now I'm back. All right, so I have to reload my brain and reload all the context into my brain again. So the issue that we had was that when we executed the DNS binary, which we compiled with google.com, then we see that we get this 2.0.0.0 IP address, but we get the same IP address for any other domain, such as weather.com. Yeah, same thing. We get a different list of results here. So here there are more results. I don't know what the difference is between those, but somehow all the IP addresses are all the same. I am wondering whether we can find out anything using the debugger GDB. So let's have a look there. So GDB, DNS. I don't know if I can already specify arguments here. So let me just say google.com. Maybe it works, maybe it doesn't. I have no idea. No, so it's misinterpreting the google.com argument as an input file and it's searching that file. So let me just quit and open it again with a proper argument, which is just the binary that we want to debug. And now let's go into our debug layout and let's pick the line that we want to debug. And I'm curious specifically what happens after getaddressinfo in line 33, which we've already had a look at. Oh, I missed the argument. Oh, damn it. Layout next. And now set arc google.com. And now we can break at 35 and run. There we are. Let's refresh and good. So currently the result is null because it's not set. And if we print, what am I doing? I said print null here. Print 0 and print result, of course, is null. So the lookup actually succeeded. But what is inside P results? That's the question. Print P results. And now let's print p results AI address. And maybe for some reason this is the value for all IP addresses, and for IPv6 the entire array is, the entire data is taken and parsed to an IPv6 address, and for IPv4 just those bytes are taken and somehow interpreted as 2000, or maybe, yeah, I don't know. I really don't know. So that contains a field as a family. I think something is wrong. Let's just try to memorize the 24p at and then 1b021. Maybe I can write that in a file or in terminal, just note it down. Wait. So let's put that in the terminal here on the below my webcam. And let's quit this application. Yes, and let's run it again with argument reddit.com, so different website. And now we use the same breakpoints, that break 35. Break 35. And then we run, and let's see, refresh, and let's print p results. Arrow AI address. I don't know. Here the address is somehow different. Okay, but that would indicate. Wait, let's note that address down as well. That could indicate that the queries are correct. But maybe we are not storing them correctly somewhere. Let's set argument to a different website again. Let's say Amazon.com. And let's run. Yes, let's run from the beginning. Next, refresh, and then print p results AI address. And this one has a different address again. That means that the address is different every time. Let me just do it one last time. Set arg whatever Samsung.com. Run from the beginning. Next, print or refresh, print, and then this, and this is again a different IP address. So maybe the lookups are correct. I'm just guessing because we just had a look at the very first lookup every time. Which would be in the case of Google.com. We had a look at this result here. So it was A0082B. If I change that to google.de for the German version, A0082A. Aha, okay, so the IPv6 address somehow changes. What if I do google.jp for Japan? That's again another IPv6 address. So the IPv6 addresses seem okay. It's just the IPv4 addresses that are broken. At least that's just my guess. What if we look up google.com, google.com's IPv6 address online? Let's just search for that. Let's go to google.com and then enter that IPv6 address. I don't know. This guy refers to some Google Cloud bucket thing here, so maybe this is indeed a correct address. Let's not bother with this too much. I think we have a bug in the IPv4 address resolution. And let's check where. Let me just turn off my linter, because these highlights here, they are very annoying, I think. Ale disable? Yeah, so now we have clear text. Sorry about that, guys. You had to look at those weird highlights all the time. Okay. Now, the IP address, where is it printed? It's printed here, and it's put into this string. And here we are converting the IP address to human readable text. Using the inet n2p function. What if we print not the IP address, but the IP string, which is the allocated character array which we declared here? It shouldn't make a difference, actually, because I understood the method in a way that it returns the same thing in both cases. There's a compiler warning, so let me just fix that. Unused, it's just the unused variable. Okay, we shouldn't use unused variables, so let's try to use this IP string, and let's go. Still the same matter. inet n2p. Okay, let's see if the for loop even works. So I will now loop over the loop through the for loop in the debugger here. Refresh, and let's print. I'm now in the first iteration. Let's print rp. So that's a struct address info pointer, and let's dereference it. And it seems to contain valid entries. If we loop through this, and then let's print rp again. It's still valid. And then the next value that we assign rp should be this one, AI next. So let's remember 5bcc0. And let's go down here. Let's refresh. And it's, wait, I have to not print the dereferenced RP, but the, right, but RP. Yeah, so it's 5bcc0, and after that there's no next result, as you can see here. So all of that looks okay to me. The AI address, I'm not sure about that. Wait, AI address is a pointer. That's a pointer. What are we doing with the pointer? I'm putting the pointer into inet into top, inet network to presentation. Let's look that up. Inet network to presentation. And we pass here a source buffer. Just a void pointer. But, aha, in case of AFINet, source points to a struct in address, which is converted to an IPv4 network address. Digit probably, but I like and the buffer destination must be at least inet address length bytes long. And source, in case of AFINet 6, IPv6, source points to a struct inet 6 address. We are not pointing to those structures. We're just pointing to this AI address field, which is, what is that? It's a socket address. So here we don't need the socket address, we need an IN address. Do we maybe have to pass simply the thing that is stored inside this AI address? What if I do RP and then access the AI address and then access the SA data? That probably won't work. Because of syntax already. Yeah. Can I just do a double arrow notation here? Just like this? Yes. Could this be a correct result? We have zeros. We have leading zeros here in the IP address. This doesn't look correct to me. It would look correct to me if it was 250.142.0.0 in the opposite order. What if I change the address, weather.com? Yeah, this looks like it's the wrong order. This is the wrong way around. What should I do? So this inet ntop function is expecting the input in network byte order. Apparently in our case we already pass it in a different order. Wait. Address. Here we get this AI address. Where is that documented? Nowhere. Man AI address. Nothing. AI address. Ah, of course, yeah, because it's a SOC address, but that wasn't documented anywhere. SOC address. Where can I find information about the SOC address? I probably go into user, include, and then grep for SOC address. Oh, that's a lot. Let's check the socket.h. SOC address. There we go. And it contains SA data, which is a 14 bytes array. Let's have a look at BJ's guide again. BJ's guide to network programming. And here we should be able to find something about getaddressinfo and then about the representation, which is, where is it? Here. So here, the author is passing as input. I hope you can see it. The AR family, the address. What's the address? It's just this void pointer here. But where is it filled? Oh. Okay, here the author takes the AI address, casts it to a socket address in pointer, which is basically the IPv4 address, and then takes from that the S in address field. How are you supposed to know that? And for IPv6, it's very similar, just with the socket address IN6. No, seriously, how are you supposed to know that? I mean, I can just copy that code, but that wouldn't be fun right now. So wait, AI address, let's look that up again. What can we find out? A pointer to the socket address is placed in the AI address field, and the length of the socket address in bytes is placed in the AI address length field. Okay. Anything else? Nothing else? Is that already it? That's already it? That's all the documentation there is. And that's a socket address. What is the socket address? Sock address. And there's no documentation on that. And if we do man sock address, there's also nothing. And if we do grep-rli sock address, there's all of that stuff. Where could it be coming from? Let's search for it. Sock address. That's this thing right here. And it contains an SA data, address data array. Yeah, but then how do you close the connection between this and the other thing for final printout? Oops. So what I would like to do is I would like to search this text for sock address, sock adder. Here. Blah, 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 blah. No, this is somewhere in the middle of the book. Maybe let's start searching from the start. And there's a reference about the struct, socket address, and pulse. Structures for handling socket addresses. Yeah, and we already found this definition here. It's a net_inet/in.h. And here this says all pointers to socket address structures are often cast to pointers to this type. All pointers to socket address structures are often cast to pointers to this type before use in various functions and system calls. So this contains the address family and the SA data. Does it really contain the address family? Yeah, it does. There it is. Okay. This means we can wait. We pass the address family as the first argument. What we do in our code is we pass the AI_family. Is that the same thing? Because we could technically also get it directly from the AI address and then the SA family. Is that a difference? No idea. No, it's the same thing. And then we do... I just had a thought and I somehow forgot it. Wait. And then there are special variants of this structure, apparently. There are the socket address IN for IPv4, and then there's IN address. And then there's the IPv6 socket address IN6. And it seems that, wait, there's a description here. In memory, the struct socket address in and socket address IN16 share the same beginning structure as the structure socket address. And you can freely cast the pointer of one type to the other without any harm, except the possible end of the universe. Just kidding on that of the universe thing. If the universe does end when you cast a struct socket address IN to a socket address, I promise you it's pure coincidence and you shouldn't even worry about it. Yeah. So with that in mind, remember that whenever a function says it takes a struct socket address, you can cast your struct socket address in, socket address IN6, or socket address storage to that type with ease and safety. And this takes as input, what does it take as input? Source. It converts the network address, source points to a struct in address, and the in address was also here. In address, there it is. So how do we get the... it's here. we have the socket address. We can cast it to socket address in and then access the in address field. And we can also cast it to IN6 and get the in6 address field. Let's go. Okay. Let's delete all of that. Create the void source. And if we have IPv6, if the family is AF INET, so it's IPv4, we can just use the ternary operator here. Then we cast, oh my god. Then we cast RP AI address. We cast that to sock address in, and then access on that, which field? The in address field. And else we don't cast it to socket address in, but to a socket address in pointer, I think. And else we access socket address in 6. We cast it to that, access the AI address like this, and then call the in address 6 or in 6 address, I think. I think here I also have to use the arrow operator. Okay, there are errors here. Let me just enable my linter. Just for a second, just to tell me what is wrong. RP AI family. If the AI family is equal to AF INET, IPv4, then we cast the AI address, the socket address pointer, to a socket address in pointer. And access on that the in address field. Else we use the socket address in 6. Yeah, all of that sounds reasonable to me, honestly. Yeah, so socket address in 6 has an S in 6 address. Oh. What does this book say? In 6 address. No, but the field is called S in 6. Okay, I have to prefix all of them with an S. So S in address. S in 6 address, and what else? I think that's okay. Wait, let me disable my linter again. So we are checking if we are using IPv4, then we cast our result to a socket address in pointer and then access on that pointer the sin address. If we are using IPv6, then we do the same thing, but we access sin6 address, which is declared here. And that sounds good to me. And there's a syntax error. I messed up somewhere. But where did I mess up? Expected expression before parenthesis token socket address in 6. Socket address in 6 is undeclared. Sock address in 6. And here it says, what does it say? Sock address in 6 undeclared. Why is it undeclared? It's declared in this header, net inet in, and we have not imported that. How is that possible? Oh god. Net inet in.h. And now it might be fine. Let's try. No. Sock address in 6 is undeclared. First use in this function. What's the first warning? It's this one. Sock address in undeclared. First use in this function. Here we cast to a sock address in. Sock address in. There it is. Maybe there's no type definition for this sock address in, and we have to prefix that with the structure. Wait. What if we do struct sock address in? Let's just save that and just do it for this one call, and indeed the warnings go away. There's no type definition for the sock address in. And if we do the same for the sock address in 6, I think that's good. And now we just have to fix up this call and fill in the source pointer, which is the source, which are the source bytes in our code. And then we should be good to go. So now the inet ntop call is taking as input the family IPv4 or IPv6. And then it's reading the source bytes from the raw DNS lookup and then it's writing the converted parsed string into the IP string, and considering of course also the length of the IP string as an input. It needs the length to know how it needs the length to work with this string, which is a pointer. Whenever you work with pointers, you need to also pass a length. Otherwise, the function does not know how to stop or where to stop. So let's compile that and execute, and we still have an error. That is this colon right here. And of course it says type mismatch, and that is because here we have a void pointer source, but we are returning either an sin address here or an in address or an in6 address, so the types don't match, and we have to cast the return values to void pointer. I think we could also do it to something else, or we could. No, let's do that. I know this line of code is really horrible, but I just want to get it working. So, and then let's go over here and let's try to execute. And there's still an error. Struct sock address in cannot convert to a pointer type. And the same for the other socket address in 6. Cannot convert to a pointer type. But it is being... No. What's the issue here? This is supposed to be a pointer to this structure. This should be completely valid, actually. And we are passing RPAI address and then the S in 6 address, and then we're... Ah, no. We are... What are we doing? We are casting the result of RPAI address to socket address in 6. Cannot convert to a pointer type. What does this mean? Struct socket address in RPAI address. I need to look that one up. Cannot convert to a pointer type. C. You are missing an ampersand. But am I? The AI address field contains, what does it contain? Oh, this is just a structure here. This S in address is just a structure. Do I have to? No. And this AI address, where is this set? This is a pointer to a socket address. So this is a pointer to a socket address. We're casting this to a socket address in pointer, which should be fine. Then we're accessing the as in address, which is an actual value. And that is the thing. That is the issue, I think. As in address, let's look that up. And that is, yes, this is not a pointer. So we have to pointerize this by accessing the address of that. Let's put an ampersand before that. And let's put an ampersand here. Let's see if that works. I don't know. This is really gobbled up syntax now. And it works. Finally. We got it working, guys. Okay, so let's perform a couple of requests. What should we do? So we have now created our own DNS lookup tool that is doing the following. We can state DNS. If we just execute it, it gives us a usage printout. So it says it wants to be called with a host name. So let's call it with google.com. And we get a list of IPv6 addresses and IPv4 addresses for the different available services. So there are different protocols that are available at this address. And this looks like a reasonable IP address. If I search for that IP address online, I get directly redirected to Google. So this seems indeed to be correct. If I search for weather.com, so then this seems to be the IP from or of the website weather.com. So let's paste this IP in, and this is an invalid URL. Maybe because this is an HTTP. I don't know. Yeah, but if I search for that online, it tells me that this is weather.com. Maybe I have to prefix that with HTTPS because there's no HTTP. I have no idea. Let's just, whatever. This is weather.com. If the search already tells us that this is weather.com, then this is weather.com. All right, next example, stackoverflow.com. And now here, this is it has two kinds of IP addresses. It looks like this one might be Cloudflare and this one might be the actual IP address. It's just a guess. Yeah. Oh no, this is part of Cloudflare, and it says direct IP access not allowed, but this is definitely, if we search for that address, this is definitely Stack Overflow. Maybe we should search for that address here. Well, they sit behind a proxy, which is Cloudflare. Ah, no, this is Stack Overflow. Okay. Stack Overflow on Cloudflare. Good guess. All right, guys. And this is it. Now we can look up any IP on the internet and we can look up any host on the internet and have it resolved to an IP address, and it's all done in pure C. And now I don't want to waste so much time talking. If you enjoyed this video, if you learned something, then leave a like, stick around, become a subscriber, and see you next time. Bye.